Hi Math 2 students, and welcome to your 5.3 Ed Puzzle. So we got our couple of definitions here. Bisect, that means when a point, segment, or ray or line divides a segment into two congruent segments. All right, so really what that means is that you have a line, and there's either another line, a point, something like that cuts it in half. And of course, when it cuts it in half, it's going to make two congruent pieces. The midpoint is a point that divides a segment into two congruent segments. So if we look at the picture I just drew, this would be the midpoint. So the midpoint bisects. All right. So for example 1, it says if XY, so that's this guy, bisects AC, what conclusion can we draw? So what that's telling you is that XY cuts AC in half. So if it cuts AC in half, we could say that it forms two congruent line segments. So we could say that AB is congruent to BC. All right? We cannot say that XB is congruent to XY because we don't know if it's bisected. But we do know that AC is bisected. So we could say AB is congruent to BC. All right. Then it says, if D is the midpoint of FE, what can we conclude? Well, if D is the midpoint, that means that it's going to cut it in half. It's going to bisect it. So we could say that FD is congruent to DE. All right, next. It says, given that OM is x plus 8, MP is 2x minus 6, and OP is 44. What is the midpoint of OP? All right, so let's go ahead and write this out here. We have O. Here's the thing, too. You kind of have to look at the information given so that you can draw a picture. This is kind of confusing. It's like, well, where does the P go? Where does the M go? What's going on? So what we're going to do here is, they're asking, is M the midpoint of OP? So what that means is we're going to have a line segment, OP. All right. And let's put M here. All right. We know it's going to be in the middle. We don't quite know if it is the midpoint. I should say we know it's in between. We don't know if it's the midpoint. Then they tell us that OM is x plus 8. And they tell us that MP is 2x minus 6. And then they tell us that OP is 44. All right, so what we can do is we just need to figure out, well, is OM equal to MP? All right, so what we can do is we'll say, well, x plus 8 plus 2x minus 6 has to equal 44. We know that, all right, because this plus this needs to equal this. You can see that's true. So we write it like blue plus green has to equal the entire thing, which is 44. So you can go ahead and solve. We get 3x plus 2 equals 44. Minus 2 minus 2. We get 3x equals 42. We're going to divide by 3. And we get that x is equal, let's see, 40. Oh, I'm sorry, we're going to divide by 3. So we do 42 divided by 3, and we get x equals 14. All right. So now we can go ahead and, let's see. Whoa, what is going on? There we go. So now we know that x is 14, so we got to see if these two line segments are equal to each other. So the blue guy, we can figure out what OM is by plugging in 14. So we're going to do 14 plus 8, which is going to give us 22. Then we're going to plug into the green guy, which is going to be 2 times 14 plus 8, which is going to be 20. Oh, my goodness, minus 6. What the heck am I doing? 2 times 14 minus 6. All right, so we get 28 minus 6, which is going to give us 22. So since these are both equal, that means that M does cut that line segment in half. So you would say, yes, M is the midpoint of OP. All right, next one. Oh, they, I didn't realize they had a picture drawn for us. Oh my God, well, oh well. Sorry for making you draw that. All right, we got the median. So the median is a line segment drawn from any vertex of a triangle to the midpoint of the opposite side. So what does this mean? Okay. So first off, of the vertex, the vertices of the triangle are going to be, the 3 points of it. All right. And it says a median is going to be drawn from a vertex to the opposite side. And then it's going to cut that side in half because it's the midpoint. All right. So for example, let's say I wanted to draw in, here, I'll draw another triangle here. And we'll label it A, B, C. Let's say I wanted to draw a a median that started at A. I would draw it from here to here. And that would mean that it would cut this line into 2 perfect equal segments. All right, so that's what that means. All right, so now they tell us that TW is the median. Then they tell us that ST is x plus 40. And one thing you guys really got to do is draw on these pictures. Or if you're able to draw on them, draw on them. Then we get that SW is 2x plus 30. And we get that WV is 5x minus 6. All right. So they told us that TW is the median. So if TW is a median, that means that this line segment has to be congruent to that line segment. And if that's the case, we can set them equal to each other. Okay, we can set 2x plus 30 equal to 5x minus 6. I want to point out, we don't know the relationship of ST to SW or WV. We can't use that at all right now. We're ignoring it. The only piece of information we have is that this guy is congruent to this guy. And the reason we have that piece of information is because they told us that TW is the median. So we're going to go ahead, we're going to say 2x plus 30 is equal to 5x minus 6. So we can go ahead and solve that. We're going to do minus 2x. We get 3x minus 6 equals 30. Add 6. We get 36 equals 3x. Divided by 3, we get x equals 12. All right? But we're not done. We actually haven't answered any of these questions yet. All we did was figure out what x is. So now what we can do is go plug in x to these different expressions. All right? So to figure out what SW is, we're going to plug in 12. So we're going to do 2 times 12 plus 30. We get 24 plus 30, which is going to give us 54. Oops. So we could say that SW is equal to 54. All right. Now, we could go ahead and plug into WV, but we already know that SW is congruent to WV. So guess what? We don't even have to do that. We know that WV is going to equal 54 as well. You could plug it in to double check, but we won't even bother. Then we got to find ST. So we're just going to plug in 12 here. And we get that ST is 52. So again, you really have to double check yourself on all these. Make sure you're actually answering the question that is asked. All right, let's try this next one. We have the term perpendicular. So lines, rays, or segments that intersect at right angles. So if it's said to be perpendicular, what the heck? You know automatically that you are going to get, here, let's see, let's make this a little bit thicker here. Whoa. We don't need that. There we go. That's a little bit better. You're going to get a right angle, all right, when you have perpendicular, or a 90-degree angle. So it says, are we able to assume that lines, rays, or segment are perpendicular? So if we look at something and we're like, oh, that looks like a right angle. No, you cannot. All right. You cannot assume that something is perpendicular. It either needs to have, you know, the little 90-degree mark, then you know it's perpendicular. But you can't just look at something. Like if I was given no information on this, I couldn't just go say, oh, that looks like a right angle. I'm going to, you know, put a right angle mark in there. Well, I don't know. Maybe it's 89 degrees, right? It might be close to 90 degrees, but may not quite be 90 degrees. So you need to either be flat out told, or you have to be able to draw that conclusion from the information given. All right. So here for example 5, it says if EH, and this is actually a new symbol that we're learning here. This is the perpendicular symbol. All right. So it says if EH is perpendicular to HG. So they're telling us EH is perpendicular to HG. So what does that mean? That means that this angle here is going to be a right angle. All right. So it says, then which angles can you conclude are right angles? So really, I guess I just kind of gave you the answer here, right? If they told us that these two are perpendicular, we can conclude that angle EHG is a right angle. All right. We cannot conclude that this is a right angle. We cannot conclude that this is a right angle because we don't have any information on that. But we can say that this is a right angle since we know that these two sides are perpendicular. All right, for example 6, it says, given that KJ is perpendicular to KM. So let's draw that in. We have KJ and KM. All right. They said this is perpendicular, so we can draw in a little box there. It says JKO is 4 times as large as MKO. So it says find JKO. All right, so this is a tricky one. But what they're telling us is that JKO is 4 times as large as MKO. All right, so let's just say MKO is X. If JKO is 4 times as large, we can say that it's going to be equal to 4 times X, right? If this is 1, that's going to be 4. If this is 2, that's going to be 8, right? If this is 10, that's going to be 40. But we got to, so we can use these variables to kind of describe what they told us here. So now it says find the measure of JKO. All right, so what the heck are we going to do here? Well, if we look, we know that this big guy here is going to be equal to 90. And we know that because we figured out these are perpendicular, which means that it makes a 90-degree angle. So what we can do is add up these two angles that make up this 90-degree angle and set it equal to 90. So we'll just say 4x plus x equals 90. You get 5x equals 90. Divided by 5, and 90 divided by 5 gives us 18. All right, so again, x equals 18, but they're asking for JKO, so we need this big guy. So we're going to do 4 times 18, which is going to give us 72. So we'll say the measure of angle JKO is 72 degrees. All right, next one. Actually, we can be done.